13 square, number of 11 sylow subgroup and 13 sylow subgroup in G என்னன்றதை find out பண்ணணும். Actually number of 11 sylow subgroup அப்படின்றது என்ன அப்படின்னு பார்த்தீங்கன்னா already by the Sylow's theorem, third part of the Sylow's theorem, the number of 11 sylow subgroup is of the form 1 plus 11k, that is of the form 1 plus 11k. அப்படின்னா the 1 plus 11k should divide 11 square and into 13 square, that is means here 1 plus 11k, that is the 13 square. Okay, so இங்கே பார்த்தீங்கன்னா ஆர்டர் ஆஃப் ஜின்றது 11 ஸ்கொயர் 13 ஸ்கொயர். ஃபஸ்ட்டு நம்ம 11 சைலோ சப் குரூப் கண்டுபிடிக்கணும், எத்தனை 11 சைலோ சப் குரூப் இருக்குன்னு. ஸோ பை த தேரம் 1 ப்ளஸ் த நம்பர் ஆஃப் 11 சைலோ சப் குரூப் இஸ் ஆஃப் தி ஃபார்ம் 1 ப்ளஸ் 11k, that should divide the 13 square, so that is for the k equal to 0, 1, 2 and so on. When you take that k equal to 0, it's become the 1. So when you take the k equal to 0, then 1 plus 11 into 0, so 1 divides 13 square, this is the truth. When you take k equal to 1, now that is the 12 varum, 12 divides 13 square, 12 doesn't divide 13 square. இது மாதிரி செக் பண்ணிட்டே போகலாம். k equal to 2 போட்டிங்கன்னா that is the 22 plus 1 23 வரும். 11 2 are 22, 22 plus 1 23, 23 is also doesn't divide the 13 square. So the only this is satisfied only for k equal to 0, and therefore n11 that is congruent to 1 modulo 11, that is n11 equal to 1, n11 equal to 1 that is the number of 11 sylow subgroup, that is n11 equal to 1, that it is must be unique. So therefore n11 equal to 1. So n11 equal to 1, that is the unique that is called the normal அப்படின்னு சொல்லுவோம், that is normal. So n11 equal to 1 by the second part of Sylow's theorem, the 11 sylow subgroup are conjugate, therefore the unique 11 sylow subgroup is normal in G, that is normal in G. Okay. அதே மாதிரி the same way 13 sylow subgroup, that is unique that is called the simple அப்படின்னு சொல்லுவாங்க, that is 11 sylow subgroup only unique that is called the simple. And here n number of 13 sylow subgroup is of the form 1 plus 13k, so that must divide the 11 square and 13 square, that is 1 plus 13k should divide the 11 square for k equal to 0, 1, 2 and so on. When you take k equal to 0, then 1 divides 11 square, obviously true. For the k equal to 1, that is 14 doesn't divide 11 square. The same way k equal to 2, that is 26 plus 1 27 doesn't divide the 11 square. So here also n13 equal to 1, the unique 13 sylow subgroup is normal, that is the 13 sylow subgroup is unique, that means the unique 13 sylow subgroup is always normal, so normal in G. Okay, so number of 13 sylow subgroup, number of 11 sylow subgroup நம்ம find out பண்ணணும், that means A என்றது 11 sylow subgroup னு எடுத்துக்கிறேன், and of order 11 square, and B என்றது normal, that is the 13 sylow subgroup, that is also normal because of unique இருக்கிறதுனால. What is the A intersection B is a subgroup of both A and B, its order divides GCD of 11 square and 13 square, that is equal to 1, that means A intersection B equal to E. So the order of AB should divides order of AB equal to order of A, order of B divided by order of A to B. That is HK ன்னு எடுத்தீங்கன்னா நீங்க இந்த ரிசல்ட் ஆல்ரெடி பார்த்திருப்பீங்க. The notation order of HK equal to order of H into order of K divided by order of H intersection K. இதை பார்த்திருப்போம். இந்த ரிசல்ட் அப்ளை பண்ணும் பொழுது that is equal to 11 square into 13 square, that is equal to order of G. A intersection B equal to identity element. This is the order of A, that is this is order of B, that is equal to 11 square into 30 square, that is equal to order of G. So G equal to AB ன்னு வருது. So A and B are groups, that is prime square order. Prime square and the P square, order of A equal to என்ன இருக்கு 11 square and order of B equal to 13 square. இது ரெண்டுமே both are the prime square, that is they are abelian. So for any A belongs to A, B belongs to B, consider the commutator AB, A inverse, B inverse. A is normal தெரியும் நமக்கு. So AB, A inverse, B inverse equal to AB, A inverse into B inverse, that is belongs to B. And B is normal, so AB, A inverse, B inverse, A into A, B, A inverse, A inverse, that is belongs to A. So therefore AB, A inverse, B inverse is obviously belongs to both A intersection B, so that is equal to identity element, so that AB equal to BA. Therefore the every element of A commutes with every element of B. Since A and B are abelian, so G equal to AB is also abelian. So any group of order 11 square, 13 square is abelian, and also both sylow 13 sylow subgroup, sylow 11 sylow subgroup, both are normal because of unique. Okay. And another problem பார்த்தீங்கன்னா that is a 72. So இங்கே order of G equal to 72, order of G equal to 72, 72 ன்றது 2 cube into 3 square எடுத்தலாம். That means prime factorization 2 na, that is equal to 36, that is 2 na, that is 18, that is 2 na 9, that is 3 na 3, that is 3 equal to 1, that is called the 2 cube into 13 3 square, the 72 ன்றது. Here I will try to prove the not simple. So simple illaiya, simple means the normal subgroup only the group and identity, that's all, no proper normal subgroup, then that is called as simple. Here number of 3 sylow subgroup is of the form 1 plus 3k. The 1 plus 3k should divide the 2 cube. Then the possibilities are k equal to 0 போட்டீங்கன்னா, that is k equal to 0 now 1 divides 2 cube. Okay, k equal to 0 for k equal to 0, and k equal to 1 போட்டீங்கன்னா, that is 3 plus 1 4, அதுவும் டிவைட் பண்ணுது பாருங்க. K equal to 1 போட்டீங்கன்னா, that is 3 plus 1 4, so 4 divides 2 cube for k equal to 1, and k equal to 2 போட்டீங்கன்னா 3 2s are 6, 6 plus 1 8, 6 plus 1 sorry 3 2s are 6, 6 plus 1 7, அது வரல, that is so only 4 divides 8, and 3 போட்டீங்கன்னா 9 plus 1 10, அதுவும் டிவைட் பண்ணாது, and 4 போட்டீங்கன்னா 4 3s are 12 plus 1 13, 13 is also doesn't divide, so the only divides for k equal to 0 and k equal to 1. So n3 is congruent to 1 mod 3, it is coprime to 3, it is coprime to 3, and n3 divides 8 also, that is n3 divides 8. The divisors of 8 are 1 2 4 and 8. The only one of the form 1 plus 3k or 1 or 4, that is 1 and 4 தான் டிவைட் பண்ணுது. So n3 equal to 1 இருக்கும், இல்லை or n3 equal to 4 இருக்கும். n3 equal to 1 இருந்தால் that is called as 3 sylow subgroup is normal. இப்போ தான் பார்த்தோம் previous ப்ராப்ளத்தில். The unique இருந்ததுன்னா that is called the 3 sylow subgroup is unique, and then it is called the normal. n3 equal to 4 na என்ன ஆகும்? That is if you take n3 equal to 4, இப்போ Pன்றது 3 cell subgroup னு எடுத்துக்குவோம். Let P be the 3 cell subgroup, N3 for the case of N3 equal to 4. Then N3 equal to, okay, P 3 cell subgroup, index of the N of P, normalizer of the P over G is order of G by order of N of P. So that means order of G is here 2 cube into 3 square. 2 cube into 3 square. Order of N of P is here 4. Then the index of this one is obviously not okay. So G over N of P is 4. N of P is the normalizer of the P. So order of N of P is order of G by order of 4. That is the index is 4. N3 is 4. Sorry, I will try to find out the N of P, order of N of P. So order of G by order of 4, order of G by 4 equal to order of N of P. Already we know that order of G is 2 cube into 3 square. So when you simplify it, that is equal to 18. So order of N of P is 18. Order of N of P is 18. Normalizer of the P. So that is consider the action G on the set 4 cell subgroup. This gives the homomorphism 5 from G to S4. So that is order of G equal to 72 doesn't divide the order of S4. So pi is not injective, that is not 1 to 1. That is the function from G to S4. And the kernel K of the pi is non-trivial normal subgroup. So that is since order of G equal to 72, that is greater than 24, N of P contains a non-trivial normal subgroup. Non-trivial normal subgroup. So that is called G is not simple. This is the explanation G as a non-trivial normal subgroup, that is G is not simple. Simple shortcut it's a very simple idea. The previous problem number of 13 cell subgroup, number of 11 cell subgroup is always unique. Okay, well, that is called the simple. Unique that is normal. Normal na unique that is called the simple. Suppose inge N3 is equal to 1 or N3 equal to 4. So N3 equal to 1 or N3 equal to 4 nave, that is not simple. That is not simple. This is only for the explanation case. So that is called the not simple. This is the x greater than 0 is the real number, that is the greatest integer function x to be m. M is the integer such that x is lies between the m and m plus 1. So x is a real number, either define to be m, and m is integer such that x is lies between the m and m plus 1. P is prime, the power of p which exactly divides n factorial is given by the n by p square plus and so on, n by p power r plus and so on. The power of p which exactly divides n factorial, that is in the form of like this. So the highest power of p that divides n factorial, highest power of p that divides n factorial, that is multiple of p, each multiple of p among the numbers 1 to n contributes at least one factor of p. The number of such multiple is n by p, the greatest integer function n by p. The same way for p square, that is the number of such multiples n by p square. The higher power n by p power r, when you add it, we get the total exponent of the p in n factorial is summation n by p power r. The highest power of p dividing n factorial is called n by p plus n by p square plus n by p cube plus and so on. So that is the terminate, then p power r greater than, p power r greater than n, that is called the terminate. This is the idea. The exponent of the prime p in n factorial is of the form summation n by p power r. The exponent of p in n factorial. So n factorial ன்றது some value. அதில் எக்ஸ்பொனண்ட் ஆஃப் பின்றது ஒரு ப்ரைம் நம்பர். பியினுடைய பவர் வந்து என்ன இருக்குது அப்படின்றத கண்டுபிடிக்கிறதுக்கு நம்ம இதை யூஸ் பண்ணுவோம். ஓகே, ஸோ சைலோஸ் p subgroup of Sn as order summation p power summation n by p power r. அதுக்கு இது யூஸ் பண்ணுவோம். சைலோ p subgroup of Sn as order p power summation n by p power r. இதெல்லாம் ரொம்ப இம்பார்ட்டன்ட். இது a standard method, that is the sylow p subgroup of Sn. First of all, partition 1 to n into the many disjoint p block as possible and a full cycle of length p inside the each block, that is add permutation that permute the block, and the sylow p subgroup as an iterated, that is the product when n is the power of p. So use the construction of sp power k, the generator of two sylow subgroup of S8, generator of three sylow subgroup of S9. But two sylow subgroup of S8, how to find out the two exponent, that is sylow subgroup exponent in 8 factorial, because the number of this one is 8 factorial. So the concept apply பண்ணீங்கன்னா 8 by 2 square, 8 by 2 cube. 8 by 2 cube is 8 ஆயிடும். அதுக்கு மேல நாம் போட முடியாது. So what is the calculation? 8 by 2 is 4. 8 by 4 na, that is 2. 8 by 8 na 1. 4 plus 2 plus 1 7. So sylow 2 subgroup as order 2 power 7, that is equal to 128. Since 8 equal to 2 cube is 8, sylow 2 subgroup of S8 is isomorphic to the iterated, that is C2 C, that is like that. So generating, that is C2's, that is iterated, the product of this C2 like that. The convenient explicit generating set is of the 6 permutation in the cycle notation, that is 1 2 3 4. Let's leave it. So the permutation generated the subgroup of order 2 power 7, which is therefore the sylow 2 subgroup of S8, which is called the sylow 2 subgroup of S8. S8 நோடைய ஆர்டர் வந்து 2 power 7 வருது. தட்ஸ் ஆல் ஐடியா. அதே மாதிரி 3 sylow subgroup of S9 கண்டுபிடிக்கலாம். 3 sylow subgroup of S9 means S9 is number of element 9 factorial. So 3 adic exponent நம்ம எக்ஸ்பிரஸ் பண்ணோம்னா இதுக்கு 9 by 3 square. Am I correct? n by p square like that. அதுக்கு மேலே போகாது. This is the 3, this is the 1, 3 plus 1 equal to 4. அப்படின்னா sylow 3 subgroup as order என்ன இருக்கும்னா அதனுடைய ஆர்டர் வந்து 3 power 4. 3 power 4ன்றது 81. ஓகே, இவ்வளோ தான் கேட்க முடியும் உங்களுக்கு. இதுக்கு மேலே ஒன்றும் தேவையில்லை. 9ன்றது that is called the 3 square, that is the sylow 3 subgroup of S9 is isomorphic to C3ன்னு கொடுத்துருக்காங்க. இதை leave it. So sylow 3 subgroup as order வந்து 3 power 4 equal to 81. இதை ஃபைண்ட் அப் பண்ணலாம். ஸோ நம்ம ஃபைண்ட் அப் பண்ணுற அந்த sylow 11 sylow subgroup, 11 13 sylow subgroup, 11 3 sylow subgroupனுடைய ஆர்டர் வந்து என்னன்றதை ஃபைண்ட் அப் பண்ணலாம் யூஸிங் திஸ் கான்செப்ட். அதே மாதிரி ஃபைண்ட் த ஜென்ரேட்டர்ஸ் ஃபார் ஜென்ரேட்டர் மீன்ஸ் தட்ஸ் மீன்ஸ் ஆர்டர். ஓகே, ஸோ 2 sylow subgroup of S6, 2 sylow subgroup of X6னா 6 by 2 எழுதலாம். 6 by 2 square, 6 by 2 cube வராது. ஓகேவா? ஸோ 6 by 2ன்றது that is the 3 plus 1 4. ஸோ sylow 2 subgroup as ஆர்டர் வந்து பார்த்தீங்கன்னா 2 power 4. 2 power 4ன்றது that is the 16. ஓகே, அது என்னன்றதை கன்ஸ்ட்ரக்ட் பண்ணியிருக்கோம். இட்ஸ் லீவ் இட். இட்ஸ் ரியலி டிஃபிகல்ட் போர்ஷன். ஸோ தட் இஸ் ஜென்ரேட்டிங் செட் என்னவா இருக்கும், தட் இஸ் 16. அதே மாதிரி 3 sylow subgroup of S6. 3 sylow subgroup of X6 means 6 by 3 அடுத்தது வந்து 6 by 3 square வராது, so that is the 2. So sylow 3 subgroup as order வந்து 3 square equal to 9, 3 square equal to 9. So that is the very important idea. So number of 3 sylow subgroup, 3 sylow subgroup, 4 sylow subgroup nuடைய order என்னன்றத using that concept you can find out. அதே மாதிரி P is a prime. The explicit generator for P sylow subgroup of SP square, SP square, that is n equal to P square. I thought generalization of this one, partition of 1 P square into the P blocks with size P. So that is the idea தான். So P square by P square by P square, that is the P plus 1. Prime தான். இதை யூஸ் பண்ணி ப்ராப்ளம் போட்டுட்டோம் முன்னாடி. So prime actually S9 S8 போட்டது இதை பேஸ் பண்ணி தான். That is the number of P sylow subgroup of order வந்து P plus 1. So the P blocks, that is that. And the number and nature of 3 sylow subgroup and 5 sylow subgroup of order 3 square and 5 square. So order of G equal to 3 square and 5 square, that is the 9 and 25, that is the 225. So that is number of 3 sylow subgroup, that is number of 3 sylow subgroup is of the form 1 plus 3k. So 1 plus 3k should divide 5 square. So only this is the possibility for k equal to 0. K equal to 1 போட்டிங்கன்னா 3 plus 1 4 ஆயிடும், 4 doesn't divide, 3 2 6 plus 1 7 divide பண்ணாது. So n3 equal to 1, that is the unique இருக்குதா, this is called the normal. Okay, by unique normal. So this is the n5. இதனுடைய ஆர்டர் என்னவா இருக்கும், that is order பார்த்தீங்கன்னா the divisor of 25 1 5 25 congruent to 1, that is the n3 equal to 1 unique 3 sylow subgroup. Unique 3 sylow subgroup nuடைய order using the previous concept apply பண்ணி நீங்க கண்டுபிடிக்கலாம், that is the order is 9. So that is normal in G. So the நாம கண்டுபிடிக்கிற 3 sylow subgroup nuடைய sylow 3 subgroup nuடைய order வந்து 9. And n3 equal to 8க்கு இது satisfy ஆகும், 8க்கு 8 3 are 24 plus 1 25, 8 3 satisfy ஆகும். So n3 is congruent to 1 or 25, 1 or 25. Okay, so that is if you take that is n3 equal to 25, the number of 3 sylow subgroup are non-normal, that is not a normal. So this is not a simple, there are the 25 of them, that is each of order வந்து 9, that is each of the order 9. And the same way 5 sylow subgroup, 5 sylow subgroup means 5 sylow subgroup is of the form 1 plus 5k, that divides 3 square. So for the k equal to 0 this is true. Okay, k equal to 0 this is true, k equal to 1 போட்டிங்கன்னா that is the 5 plus 1 6, 6 doesn't divide. So n5 equal to unique தான் இருக்கும், unique this is the normal. Unique வந்து n5 congruent to 1 mod 5, n5 equal to 1 மட்டும் வந்ததுன்னா the number of 5 sylow subgroup is normal. So the divisor of 9 பார்த்தீங்கன்னா 139, that is the only 1 is congruent to 1, therefore n5 equal to 1, number of 5 sylow subgroup is normal. அதனுடைய order என்னன்னு பார்த்தீங்கன்னா we can try to find out the order is that is another 25, order is 25. So that is each number of அந்த ஒரே ஒரு 5 sylow subgroup, that is called the order வந்து 25 is normal in. So therefore at least the 5 sylow subgroup is always normal, that 3 sylow subgroup may or may not be normal. So both the sylow subgroup are normal in the case of n3 equal to 1 also. So therefore G is direct product of the sylow subgroup P3 cross P5. So that means this is not a simple 5 sylow subgroup is let's leave it. So number of 5 sylow subgroup is normal, that is unique normal, that is the number of 5 sylow subgroup is and but number of 3 cylo subgroup is not a normal, is not a normal in the case of the n3 equal to 25. So this is basically the G is not simple here, G is not simple. And order of G equal to 30, 3 cylo subgroup must be normal, both are normal because of order of G equal to 3 cylo subgroup is of the form 1 plus 3k. 1 plus 3k should divide 3 cylo subgroup 2 into 5. So these are possibilities, that is k equal to 0, then this is divides 1 divides 2 into 5, and k equal to 1 potengna, that is called the 4 doesn't divide 2 into 5. So n3 equal to 1, n3 equal to 1, that is unique 3 cylo subgroup, therefore it is should be more normal. The same way number of 5 cylo subgroup is of the form 1 plus 5k, that divides 2 into 3. So number of 5 cylo subgroup for k equal to 0, this is 1 divides 2 into 3. For k equal to 1, that is 6, so also divides 2 into 3. Number of 5 cylo subgroup. So 3 cylo subgroup is normal. So that is n3 equal to unique 3 cylo subgroup, but 5 cylo subgroup is n5 equal to 1 mod 5, and n5 divides 6. Oh, this is also divides n3 1 plus 3, 3 3 are 9, 1 plus 3k divides 2 into 5. This is true for k equal to 3 also. So the k equal to 3, that is 9 plus 1 is 10, that is 2 into 5. So n3 divides 10 and n5 divides 6. Both are not unique. n3 congruent to 1 mod 3 and n5 congruent to 1 mod 5, as well as n3 divides 10, n5 divides 6. 3 cylo subgroup and 5 cylo subgroup. So the n3 is belongs to 1 or 10, that is n5 belongs to 1 comma 6. So that is that both are 3 cylo group and 5 cylo subgroup is not normal, that is not simple. So neither 3 cylo subgroup is unique, that is n3 எதுவுமே யூனிக் கிடையாது, that is n3 equal to 10, n5 equal to 6. So each 3 cylo subgroup as order வந்து 3 and contributes to non-identity element, that is 3 order 3 na 1 identity element இருக்கும், மிச்சம் 2 non-identity element இருக்கும். அதே மாதிரி 10 distinct 3 cylo subgroup, that is 10 into 2, that is equal to 20 element. 10 into 2 மொத்தம் வந்து 20 elements எடுத்துக்கலாம். ஓகே, மொத்தம் n3 equal to divides equal to 10ன்றதுனால ஸோ 20 elements of order 3 இருக்குது. அதே மாதிரி 5 cylo subgroup பார்த்தீங்கன்னா as order வந்து 5, as order 5 and contributes 4 non-identity element, 4 non-identity element. மொத்தம் வந்து 6 இருக்கு இங்கே, 6 distinct 5 cylo subgroup. அப்படின்னா 6 into 4 24 elements of order வந்து 5 இருக்கும். The set of non-identity element are distinct. So together they would give the 20 plus 24, 44 non-identity element இருக்கும், which is impossible in the group of size 30ல. group of size 30ல பார்த்தீங்கன்னா, ஏன்னா ஆர்டர் ஆஃப் ஜிஏ இங்கே 30 தான், இதில் வந்து 44 non-identity element இருக்குதுன்றது that is contradiction, that is wrong. Therefore at least one of n3 or n5 must be 1 இருக்கணும். n3ஓ இல்லை n5ஓ 1 மட்டும் தான் இருக்க முடியும், that is 10ஆவோ 6ஆவோ இருக்க முடியாது. So at least one of the cylo subgroup of order 3 or 5 is normal in G. Okay, that is the idea, very important one. Okay, CSIR netல கூட இது மாதிரி questions options கேட்டிருக்காங்க. And இதே மாதிரி பார்த்தீங்கன்னா that is the second part from the 40A. Every 3 cylo subgroup and every 5 cylo subgroup of G must be normal in G. So from A, at least one of the 3 cylo subgroup or 5 cylo subgroup is normal. ஏதோ ஒன்று at least ஒன்னாவது வந்து நார்மலாக இருக்கணும். Suppose now P5 is a normal subgroup, normal cylo 5 subgroup அப்படின்னு எடுத்துக்கிறோம். And the is symmetric if cylo 3 subgroup is normal. So P3 be any cylo 3 subgroup of G. P5 ன்றது normal cylo 5 subgroup. P3 ன்றது any 3 sylow subgroup of G. Order of P5 வந்து 5, order of P3 is 3. So both are relatively prime. Okay, 5 and 3. So and P5 is normal. P5 ன்றது is normal. அதை அஷ்யூம் பண்ணியிருக்கோம். P5 is normal அஷ்யூம் பண்ணியிருக்கோம். So the product பார்த்தீங்கன்னா P5 into P3 is a subgroup of G of order P5 into P3, that is equal to 15. So subgroup of G. So H is the subgroup of G now, that is index of H over G is equivalent to 2, that is 30 by 2, 30 by 15, that is 30 by 15 is 2. So index 2 இருந்தால் that subgroup is normal. நிறைய ரிசல்ட் பார்த்தோம், ஞாபகம் இருந்ததுன்னா index 2 இருந்தால் the subgroup is normal. So H is normal வந்துடும். So the group H of order 15, that is 3 into 5 by Sylow's theorem inside H, that is n3. அது Hக்கு நீங்கள் கண்டுபிடிச்சிக்கணும். n3 of H congruent to, that is the number of 3 Sylow subgroup, 1 plus 3k divides 5. So divides 5 now, that is should be only 1. அதே மாதிரி n5H, that is the number of 5 Sylow subgroup, 1 plus 5k divides 3. Okay, divides 3 na, and what are the possibilities? Only 1 da. So n5 of H 1 da. So 3 Sylow subgroup, 5 Sylow subgroup of H வந்து யூனிக்காக இருக்குது. யூனிக்காக இருந்தால் that is நார்மல்னு அர்த்தம். So normal in H, but H is normal in G, but H is normal in G. So therefore, so conjugation by any element of G, since the Sylow subgroup, subgroup of H to another Sylow subgroup of H, that is uniqueness in H forces the Sylow subgroup to be fixed by all conjugation in G. Therefore Sylow 3 subgroup, Sylow 5 subgroup are normal in G, that is Sylow 3 subgroup, every Sylow 3 subgroup and every Sylow 5 subgroup of G is normal. Okay, that is the idea. And GS normal subgroup of order 15, and another one GS a normal subgroup of order 15. So that is from the previous result, the Sylow 5 subgroup is normal, and then for any 3 Sylow subgroup, the product of P5 and P3 is a subgroup of order 15. The same, that is Sylow 3 subgroup is normal, multiplying with this the Sylow 5 subgroup, that is yield the 15. So either case the subgroup H of order 15 as index 2, therefore this is the normal. So therefore G has a normal subgroup of order 15, and that is classify all groups of order 30, that is N is a normal subgroup, that is unique, normal subgroup of order 15, and 15 is 3 into 5, GCD of 3 comma 5 equal to 1. So N is isomorphic to C15. C15 is nothing but C3 into C5, that is the 15. That is therefore G is isomorphic to C15, is that is the corresponding the function to C2, that is pi is defined as C2 to automorphism of C15. So the elements of order 2 acts as the conjugation on N, that this classification determine the possible homomorphism pi, the possible images, and automorphism C15, that is isomorphic to Z by 15Z, that is means Z15. Therefore pi of 15 equal to pi of 3 into pi of 5, that is equal to 8. So that is the elements of automorphism of C15 of order dividing 2. Okay, it's a very big concept. The different non-isomorphic groups of order 30. So 4 non-isomorphic groups of order 30, that is C30, D15, D5 into C3, S3 into C5, like that. So basically நம்ம தெரிஞ்சிக்க வேண்டியது இதில் number of 11 Sylow, number of P Sylow subgroup எப்படி கன்ஸ்ட்ரக்ட் பண்ணுறதுன்னு தெரிஞ்சுக்கிறோம். நம்பர் ஆஃப் பி சைலோ சப்குரூப் இஸ் யூனிக்காக இருந்ததுன்னா தட் இஸ் நார்மல், அது யூனிக்காக இல்லைன்னா தட் இஸ் கால்ட் த சிம்பிள், தட் இஸ் நாட் எ simple. And G is a group of order 231, that is the 11 sylow subgroup is in the center of G, is in the center of G. So order of G equal to 231, 3 into 7 into 11 எடுதலாம். இங்கே 11 sylow subgroup நீங்கள் construct பண்ணால் that is the 1 plus 11k should divides the 3 into 7, should divides the 3 into 7. இங்கே பார்த்தீங்கன்னா that is k equal to 0 க்கு this is true, k equal to 1 போட்டிங்கன்னா 22 plus 1 23, is it is it true? 7 into 3 21, 22 plus 1 23, okay. And n elements divides 21. What about the k equal to 2? No, that means 22, 1, 11 plus 1, 12. K equal to 1, no, that is 12 doesn't divide 7, 3 is 21, 2, 3, 33, 34. It's not equal. How to divide the 21? Is it correct? 231, that is when you divided by 3, that is the 7 3s are 21, that is 7 3s are 21, that is 7, that is 11, that is 11. So 3 into 7 into 11, that is n 11. I thought k equal to 0, 1 plus 0, that is divide 3 into 7, okay. K equal to 1 means 1 plus 11, that is 12. 12 divides 3 into 7, not divides 3 into 7. K equal to 2, 2 11s are 22. 22 plus 1, 23. 23 doesn't divide the 3 into 7. I thought this is not possible. So that for n11 is unique. Unique, this is the normal. Okay, 11 sylow subgroup is normal. When you move for that 7 sylow subgroup, this is the unique, this is the normal, and 7 sylow subgroup means that is 1 plus 7k divides 3 into 11. So k equal to 0 obviously true, k equal to 1 means 8, k equal to 2, no, 2 7s are 14 plus 1 15. 7 3s are 21 plus 1 22, so this is not possible. So only this is the n7 equal to 1, okay, modulo 7. Remember, the G is a group of order 385, that is 11 sylow subgroup is normal and its 7 sylow subgroup is in the center of G. So the previous result is belongs to the center of G. That is the proof. Yeah. So P11, 11 sylow subgroup P11 is unique and therefore it is normal. Okay. Eleven sylow subgroup, I give the name P11, that is the unique. Therefore, this is normal in G. So the conjugate action G on P11, this yields a homomorphism from pi from G to automorphism of P11. Automorphism of P11. Okay, I will try to prove this is belongs to center of G. So the P11 is isomorphic to C11, so that is automorphism of P11. Number of elements of the automorphism of P11, that is equal to pi of 11, that is equal to 10. Okay, 11 into 1 minus 1 by 11, that is 10. So the image of pi of G as order dividing 10, or as order dividing 10. So the number of index of kernel pi over g, kernel pi of g, that is equal to order of pi of g divides order of 10. Order of pi of g divides order of 10, that is order of g equal to 231. GCD of 231 10 வந்து 1. So the only possibility of index of kernel pi order g equal to 1. Therefore kernel pi equal to g. Kernel pi equal to g. Therefore every element of g is centralized the P11. That means the P11 is a subset of contained in Z of g. Contained in Z of g. Center of g. Okay, and the result now the order now and G is a group of order 385. So that is 11 cell group is normal. That is a very simple idea. So 11 cell group 385 5 into 7 into 11 eduthalam. So 1 plus 11k divides order of g. Order of g intrathu that is 385. 385 means 5 into 7. Correct? So k equal to 0 this is true. K equal to 1 pottingna 11 plus 1 12 not true. 2 pottingna 2 11s are 22. 22 plus 1 23 not true. 33 plus 1 34 is not true. Correct? So this is also unique. Okay, so n11 equal to 1. Is it possible? That is not possible. So the divisor that is unique means 11 cell subgroup is normal. Unique, that means normal. அதே மாதிரி 7 cell subgroup பார்த்தீங்கன்னா 1 plus 7k, that is divides 5 into 11. K equal to 1 போட்டீங்கன்னா that is called 0 obviously true, that is 1. 1 போட்டீங்கன்னா that is 8. 2 போட்டீங்கன்னா 14 plus 1 15. 3 போட்டீங்கன்னா 3 7s are 21 22. And so 4 போட்டீங்கன்னா 4 7s are 28. 5 7s are 35 36. Is it possible 55? So n7 n7 is also unique. I thought n7 is equal to unique. Therefore sylow 7 group is unique and normal. That is the idea. So when you apply the previous theorem, that is the function from G to automorphism of P7 isomorphic to something, that is the number of automorphism of P7, that is equal to 6. So when you use the kernel concept, the index of kernel psi, that is divide 6, that is the order of g equal to 385. So 385 and 6 on the co-prime. So therefore the g index of kernel pi is over g is equal to 1. Abna kernel psi equal to g. Therefore P7 is the contained in Z of g. Okay. So in the idea கொஞ்சம் important. So இதில் நிறைய கொஞ்சம் கன்ஃபியூஷனாக இருக்குது. Leave it, that is divides 5 into 11 கொடுத்துருக்காங்க. Don't confuse. Only simple idea. The number of 7-sided subgroup means 1 plus 7k should divide and this is the 3 into 385. Yeah. 1 plus 7k divides 5 into 11. அதை செக் பண்ணணும். அதை செக் பண்ணுறதுக்கு தான் இங்கே கொடுத்துருக்காங்க. ஸோ நீங்கள் சிம்பிளாக இந்த k equal to 0 1 2 3 போட்டு பார்த்தீங்கன்னா இதை விட வேல்யூ அதிகமாகும் போது ஸ்டாப் பண்ணிக்கலாம். இதில் k equal to 0க்கு மட்டும் ட்ரூவாக இருந்ததுன்னா தட் இஸ் நம்பர் ஆஃப் 7-sided subgroup யூனிக்னு அர்த்தம். யூனிக்காக இருந்தால் நார்மலாக இருக்கும். நார்மலாக இருந்தால் சிம்பிளாக இருக்கும். ஸோ இதில் ரெண்டுமே வந்து நார்மல் தான் அது. அதனால் தீஸ் ஆர் சிம்பிள் sylow subgroup. Okay, simple group. அதே மாதிரி G is of order 108. G is of order 108. And G is a normal subgroup of order 3 power k. Order 3 power k. Order find up பண்றதுக்கு நாம ஏற்கனவே யூஸ் பண்ண the greatest integer function n by p square like that அது மாதிரி கண்டுபிடிக்கலாம். sylow 7 subgroup, sylow 5 subgroup னுடைய ஆர்டர் கண்டுபிடிக்கலாம். அந்த கான்செப்ட் ரொம்ப இம்பார்ட்டன்ட். ஸோ இங்கே பார்த்தீங்கன்னா the order வந்து 108. G as a normal subgroup of order 3 power k. 108 என்றது 2 square into 3 cube எழுதலாம். Now so number of 3 sylow subgroup பார்த்தீங்கன்னா 1 plus 3k should divides 2 square அப்படிங்க ரெண்டு வரும் இது கரெக்டா இப்போ ரெண்டு வரும் that is the k equal to 0 க்கு பாத்தீங்கன்னா this is the unique-ஆ இருக்கும் k equal to 1 போட்டீங்கன்னா 4 வரும் so 4 divides 4 so this is true this is true இப்போ n3 ன்றது belongs to 1 4 so n3 equal to 1 னா this is the unique normal சொல்லலாம் and n3 that is I give the name p3 for that and the 3 cell subgroup p3 order of p3 பாத்தீங்கன்னா that is the 3 power 3 order of 3 ன்றது பாத்தீங்கன்னா that is the 3 power 3 that is equal to 27 so for k equal to 3 so therefore n3 equal to 4 எடுத்தீங்கன்னா that is we want to construct the function that is g by the conjugation on the set s of order 4 s of the 4 3 sylow 3 subgroup that is define the function pi from g to s4 k equal to kernel pi அப்படினு எடுத்துக்கலாம் that is k is normal subgroup of g by k is isomorphic to the subgroup of s4 so index கண்டுபிடிச்சனா order of g by k that is the quotient set and divides the s4 that is the 24 so g by k also divides the order of g equal to 108 that is index of g over k divides gcd of 24 108 12 so g by k is the index of order of g over k that is 1 2 3 4 6 12 that is the 12 node order so 12 node divisor இது so order of k into 108 is something இது simply பண்ணீங்கன்னா we get the result so in every case 9 divides order of k it contains the sylow 3 subgroup q of k order of q greater than equal to 9 that is k is a normal subgroup so 3 sylow subgroup of k that is invariant conjugation by g so the possible order of k case by case k has a unique 3 sylow subgroup so sylow is characteristic in k that is therefore the normal in g okay so order of k equal to என்னவா இருக்கலாம்னா 108 இல்ல 54 and 27 or 18 or 9 so that is the divisibility of the concept so n3 is equal to 4 na this is the case arise ஆகுது so sylow 3 number must be 1 ஆ தான் இருக்க முடியும் so therefore k equal to g na that is n3 k equal to is the idea so it's leave it it's a very simple idea simple ஆ தான் question கேட்பாங்க இத பேஸ் பண்ணி normal or simple ஆன தான் கேட்பாங்க and so from this g has a normal subgroup of order 3 square g has a normal subgroup of order 3 power k that is 3 square 3 cube and so on okay for the order 108 for order 108 and another one pathina g order of g equal to pq and p is less than q both are primes distinct primes if p doesn't divide q minus 1 p doesn't divide q minus 1 na g is cyclic this is a very very important result okay and p divides q minus 1 na there exists a unique non-abelian group that is up to isomorphism there exists a unique non-abelian group of order pq okay p divides q minus 1 and p doesn't divide q minus 1 p doesn't q minus 1 that is g is cyclic and p divides q minus 1 and there exists a unique non-abelian group of order pq okay and the result is very important அதே மாதிரி 3 order pqr இருக்கு இது ரொம்ப important and GBA group of order PQR with P less than Q less than R some 3 prime இருக்கு 3 primeல ஒன்னு பெருசா இருக்கு ஒன்னு சின்னதா இருக்கு that is distinct prime இது எல்லாமே distinct primes so R sylow subgroup நம்ம கண்டுபிடிக்கணும்னா இருக்கிறதுல R is the biggest prime R sylow subgroup is normal in G R sylow subgroup is normal in G so G has a normal subgroup of order QR G has a normal subgroup of order QR and Q doesn't divide R minus 1 Q sylow subgroup of G is normal in G so for example this is the 2 into 3 into 7 illa 5 கூட போட்டுக்கலாம். This is the 7 is the R here, so that is the 7 sylow subgroup. 7 sylow subgroup is normal in G, and G as a subgroup, G as a normal subgroup, of order வந்து பாத்தீங்கன்னா that is the 3 into 7 21. G as a normal subgroup of order 21, and Q, what about the Q? Q is called, this is the 3 doesn't divide 7 minus 1 இருந்ததுன்னா that is the 3 sylow subgroup of G is normal சொல்லலாம். but here divides 3 divides 6 அதனால அது சொல்ல முடியாது. maybe இங்க 5 போட்டிங்கன்னா that is the 2 into 3 into 5 னா then 3 doesn't divide 5 minus 1 ன்னு சொல்லலாம். then Q sylow subgroup, 3 sylow subgroup is of G is normal in G அப்படின்னு சொல்லலாம். ஸோ இதை ஒரு ஃபார்முலாவாக மெமரி பண்ணிட்டீங்கன்னா that is the best. ஓகேவா, டைரெக்டாக ஆன்சர் பண்ணலாம் வித்தவுட் கேல்குலேஷன், வித்தவுட் ஐடியா, without using any idea. Only in the case of this type of orders. The another very important result, order of G equal to P square Q. P, Q are both are primes. Then G has a non-trivial normal subgroup. இப்போ P square Q like that இது மாதிரி இருந்ததுன்னா non-trivial normal subgroup இருக்குன்னு அர்த்தம். அப்படின்னா என்ன அர்த்தம்னா this is not a simple ன்னு அர்த்தம். This is not a simple. So in the case of order of G equal to 2 square illa 2 square into 3, that is 12. Order of G equal to 12 is not simple because of this in the form of the 2 square into 3. So that is 2 square into 3 now, that is called with PQR primes. So G has a non-trivial normal subgroup. Now that is not simple. Okay, so in the result apply பண்ணி சொல்லலாம். This is a very important point. The same way, order of G equal to P square Q, and the same like that 3 square into and 5, that is 9 5s are 45. So 45 order 45 order of G is in the form of the either P sylow subgroup or Q sylow subgroup of normal. ஒன்று 3 sylow subgroup இல்லை P sylow subgroup or normal இருக்கும். Okay, then in the case of the P square Q, okay, either or. So mostly TRB பொறுத்த மட்டும் இது மாதிரி சிம்பிளாக தான் கேட்பாங்க. இது மாதிரி ரிசல்ட் அப்ளை பண்ணியே போடுற மாதிரி ரொம்ப காம்ப்ளிகேட்டடாக கொஸ்டின்ஸ் வரது வாய்ப்பு கம்மி. பட் நெட் எக்ஸாமுக்கு இன்னும் கொஞ்சம் நிறைய எக்ஸ்ட்ரா நான் சொல்லிக்கிட்டு டீட்டெயிலாகவும் நம்ம தெரிஞ்சுக்கிட்டா தான் நம்ம நெட் எக்ஸாம் ஃபேஸ் பண்ண முடியும். அண்ட் this is a G is a finite group in which AB, G is a finite group, GB a finite group in which AB whole power P, A power P into B power P. For every A comma B belongs to G, where P is a prime dividing order of G. So P sylow subgroup of G is normal in G. Okay, and that is a G inறது ஒரு finite group. இதில் வந்து பார்த்தீங்கன்னா AB whole power P equal to A power P, B power P ன்றது for every A comma B belongs to G. அப்படி எழுத முடிஞ்சுன்னா P ன்றது prime number. P is a prime. So that is dividing order of G. Okay, dividing order of G. Then the P sylow subgroup of G is normal. In G ன்னு சொல்லலாம். And capital P is the P sylow subgroup of G. Then there exists a normal subgroup N, that is P intersection N equal to E and Pn equal to G, and G has a non-trivial center. Okay, result ஞாபகம் வச்சுங்க. That is the same result. That is the G is a finite group. G is a finite group and it's a p sylow subgroup. Capital P lies in the center Z of G. There exists a normal subgroup N, that is a normal subgroup of G, that with P intersection N equal to E, P n equal to G. Okay, G is a finite group. Okay, and p sylow subgroup lies in the center. P sylow subgroup lies in the center now. Then there exists a normal subgroup that intersect with the P is only the identity element, and the product of the normal subgroup, the exist of the normal subgroup and the P should be equal to the given group, finite group G. Okay. And H is a subgroup of G, and N of H is the normalizer of H. That means என்னன்னு தெரியும் நமக்கு, that is commute னு எழுதலாம். Okay, இங்க பாத்தீங்கன்னா that is left coset is equal to right coset of H for every x belongs to G. இல்ல xh x inverse equal to H னு எழுதலாம் சரி, இல்ல xh equal to hx னு எழுதலாம் சரி. So that is the collection is called the N of H. If suppose P is a p sylow subgroup of G, p sylow subgroup of G, then N of P equal to N of P. Then N of P equal to N of P. H into the subgroup. H into the subgroup of G. Remember, that is the p sylow subgroup, that is called the capital P. Suppose AB are in the center of P. AB is the center of P, that is the Z of P. Center of P. Suppose A equal to XB X inverse for some X is belongs to G, then there exists a Y belongs to N of P such that A equal to YB Y inverse. So net exam konna use agum, but TRB ki avlo problem irukadu. And a GBA group of n by n matrices. GBA group of n by n matrices over the integer modulo P. Integer modulo P means ZP. Integer modulo P, and P is a prime number, which are invertible. The collection is invertible. What is the p sylow subgroup of G? What is the p sylow subgroup of G for this? So order of G inradhu, that is we can find out using the formula very starting le paathirupom. P power n minus 1, p power n minus p, p power n minus p minus 1. This simply panninga p power n into n minus 1 divided by 2 into m nu varum. That is the idea. So நாம இப்படியே ஞாபகம் வச்சுக்குவோம். So where p doesn't divide m, doesn't divide m na, where p doesn't divide m, the subgroup U of the upper triangular matrices with ones on the diagonal, upper triangular matrix with ones on the diagonal as order வந்து p into n minus as order வந்து p into p power n into n minus 1 divided by 2. Okay, that is என்ன சொல்றாங்க, that is the subgroup U of upper triangular matrices. Upper triangular matrix na, that is the diagonal la 1 இருக்கணும், and that is some entries are there. Okay, lower full of is 0, and then this is the subgroup. So நாம என்ன சொல்றோம்னா p sylow subgroup exist ஆகுதுன்னு சொல்லணும். p sylow subgroup is exist ஆகுதுன்னு சொல்லணும். That is இதனுடைய ஆர்டர் பாத்தீங்கன்னா, what is the order diagonal as order பாத்தீங்கன்னா p power n into n minus 1 divided by 2 இதனுடைய ஆர்டர். So this is the only one element, that is the order வந்து p power n into n minus 1 divided by 2. So and is a p group, this is called the p group, that is the sylow p subgroup னு சொல்லுவோம். This is called the sylow p subgroup அப்படினு சொல்லுவோம். So what is the p sylow subgroup of G? Like this general linear group over ZP. என்ன p sylow subgroup na, the upper triangular matrices with ones on the diagonal, upper triangular matrix and ones on the diagonal, and that is called the sylow p subgroup. Okay, sylow p subgroup. Okay. The possibility of the 11 sylow subgroup and 7 sylow subgroup, 5 sylow subgroup of order 5 square 7 into 11. So once again, this is the 11 sylow subgroup means NP denote the number of sylows of a subgroup. The number of 11 sylow subgroup is of the form 1 plus 11k. That should divide the 5 square into 7. 5 square into 7. That is 5 square into 7. K equal to 0 na obviously true. K equal to 1 na 12. K equal to 2 na 23. K equal to 3 na 34. K equal to 4 na 44. 44 plus 1 45. Okay, 45. K equal to 5 na 56. K equal to 6 na 60. This is the 175. Okay, so I will try. This is the unique. This is always unique. Unique na this is the normal. Okay, a possible number of 11 sylow subgroup தான் கேட்குறாங்க. அதே மாதிரி number of 7 sylow subgroup 1 plus 7k divides 5 square into 11. So 5 7 that is also unique. But number of 5 sylow subgroup, that is 1 plus 5k should divide 7 into 11. Idhula pathina that is 0 போட்டிங்கன்னா obviously true, and 1 போட்டிங்கன்னா that is 2 போட்டிங்கன்னா 10 plus 1 11 வருது. n5 equal to 1 or 11. That is not simple. That is not a normal. Not simple. So here G is A3 S3 and A equal to generated by the element of S3 1 2 in G. What are the double cosets AXX AXA of A in G? So what are the double cosets? What is the A first of all? A என்றது generated by 1 2 na, that is only possibility E12 மட்டும்தான். இதனுடைய டபுள் கோசெட் கண்டுபிடிக்க சொல்கிறாங்க. டபுள் கோசெட் அப்படின்னா ஏஇஏ கண்டுபிடிக்கணும். அண்ட் A13 ஏ ஃபைண்ட் அவுட் பண்ணலாம். தட் இஸ் these are partitions AS3. தட் இஸ் ஏன்றது உங்களுக்கு தெரியும். தட் இஸ் when you try to find out, this is like this. மல்டி பண்ண தெரியும் பெர்முடேஷனை. The same way double coset for AXB. Okay, that is AXB and A comma B in G. So AEB, A13B, A132B. So each of size on the 8 and the partition of S4. And dihedral group pathina of order 18 generated by A square equal to B power 9 equal to E, AB equal to B inverse A. The number of double cosets H for HK in G, H equal to generated by A and K equal to generated by BQ. So these are examples. It's not important, but S3 S4 லாம் தெரிஞ்சுக்கணும். And direct product in group theory. So that is the direct product AB be a group. The direct product is defined as the collection of the A comma B. The collection of A comma B, that is A is belongs to A and B belongs to B, and that is define the component wise multiplication like this: A1 B1, A2 B2, that is A1 A2 and B1 B2. Then G is a group with identity. What is the identity for this one? EA and EB. That is EA means that is identity element corresponding to A, EB means identity element corresponding to B. இதனோட இன்வர்ஸ் வந்து A இன்வர்ஸ் கமா B இன்வர்ஸ் ஆர்டர் பேர் மாதிரி கன்ஸ்ட்ரக்ட் ஆகும். ஓகே, ஸோ ஸ்டாப் ஹியர். ஸோ இன்றைக்கி பார்த்தது ரொம்ப இம்பார்ட்டண்ட் கான்செப்ட், the 11 sylow subgroup and P sylow subgroup.